Hello and welcome to this tutorial. We will explain the data output of the SIG 2D as well as the 3D laser scanner MRS-1000 using the same telegram structure. After mounting the scanner in its mounting bracket, in our example an LMS-1000, we connect the scanner to the power supply and to our computer via Ethernet. The next step is to start SOPAS, as we will use the SOPAS terminal as an example. After opening it, you will see that the main window is split into two sections, the project view on the left side and a list of available devices on the right side. Add the device to your project using drag and drop. If there are issues with the IP address connection, click on the edit icon on the device box to make adjustments so that the IP address matches to your PC. Open the drop-down menu on the right top corner and choose Open Terminal. For a better view, we are switching to a full screen mode. Here we can see a command line on the top with a framing code on both ends, which marks the start and the end of the commands. Now we can fill in the command to receive measurement values. Therefore, we will use the LMD scan data command. There are two options for the LMD scan data telegram. By sending the polling telegram SRN LMD scan data, the sensor will send the measurement values of the last scan only, and our terminal program will output those like this. The green arrow shows the command sent to the scanner and the blue one shows its answer. By clicking on the blue arrow, we will see the full measurement values in the window below. They are separated into HEX and ASCII view. We will have a closer look on the ASCII. First, we see our sent telegram. Then comes the sensor telegram acknowledge as front header, which contains status information about the device, like its serial number, a status of the in and output, timing, etc. Then it is followed by the number of echoes received by the scanner, beginning by the word dist before every measurement value of the respective echo. To simplify this example, we have limited the measurement angle from 80 to 87.5 degrees for the purpose of this video. The preset start angle can be seen here, and the next position is showing the angular resolution, which corresponds to 0.25 degrees in this case. So the scanner emits a new distance value every 0.25 degrees until the end angle is reached. It is the same process for every echo. Echo 1, Echo 2, Echo 3. Notice that the end header shows no information. If instead we send the telegram SEN LMD scan data 1, the scanner will permanently send all measured values. The terminal program shows a continual telegram output. To end the continuous data transfer, simply send the use command once again with a 0 off instead of 1 for on. There are different options to customize the LMD scan data telegram. It is possible to change the information by adding RSSI data, which shows the remission values, adding timestamps, etc. This results in a new telegram like this. The remission values of its respective distance measurements are given in the telegram. RSSI 1 belongs to distance 1, which is the first echo. RSSI 2 belongs to distance 2, and so on. The end header now contains information about the local scanner date and time, application name, and so on. In contrast to scan data telegram of the 2D laser scanners, the MRS-1000 as a 3D multi-layer laser scanner includes a specific code for each layer in its telegram to indicate which measured values belongs to which layer. The output sequence of the layers is 2, 3, 1 and 4. Therefore, the start of the measurement values for the specific layer is marked with its specific layer code. The echo information holds the same telegram format for every layer as the 2D laser scanners. The detailed telegram description can be found in the telegram listing document. This tutorial introduced the data output of the different SIG 2D laser scanners and the MRS-1000 3D laser scanner.